Hello, beautiful people. In this video, we are continuing our practice test for our Unit 6A. Now, in this part 3, we're going to be talking about interest rates and compound interest to be specific. If you wanted to watch the graphing and the sequences and series part, those are going to be part 2 and part 1. As always, disclaimer time, I am human. If I make a mistake, let me know where the mistake occurs. All right, beautiful people, let's go ahead and get started with this one here. We're starting with number 15. Castle invests $3,142 in a savings account with a fixed annual interest rate. Again, fixed annual interest rate meaning the interest rate does not change throughout the year. And it is at 7% and it compounded continuously. This continuously is your key word. So we start out with $3,142. That's your principal. Your interest rate is 7%, or you can say 0.07 since we are converting that to a decimal. It is compounded continuously, and we would like to know the balance after 5 years. So our formula is A equals P times E to the RT power. Our original principal is $3,142 times E to the rate 0.07 times our year amount. Typing that all into my calculator, 3142 times E to the 0.07 times 5 power. And I'm actually going to show you this on my calculator because you can just type this in all the way without simplifying this. Just make sure you have your exponent in parentheses. You're going to press enter and acquire your answer. In this case, it is $4,458.71. Moving on. John invests $4,153 in a savings account with a fixed annual interest rate of 9%, so 0.09. Our original starting amount is $4,153, which is your principal. It is compounded continuously. Again, keyword is continuously. How long? So time is something that we don't know for the account to equal 6,513.20. So here is our formula. A is equal to P times E to the RT power. And we have our principal, which is $4,153 times E to the rate, which is 0.09. And then we have T, which is the time unknown. Now, our ending balance is $6,513.20. Now, when you're dealing with something like this, you want to make sure that you are undoing in the correct format. Notice that your unknown is your time, which is in the exponent spot. Now, there are multiple ways to solve this. I'm going to show you how to use same base in order to find what your value is for this example. So, get rid of your principal by dividing both sides. Using my calculator, 6513.20 divided by 4153. And that gives me 1.5683120. Now you want to get as precise as you can with these decimals because we are talking about money. Okay, now that we're here, we're going to use the same base property. So you're going to say e to what power gives you this value, and you're going to set that equal to e to the 0.09 times t. Once you get this value here, you're going to say 0.09 t is equal to whatever that value is, and then we get to say t is equal to blank. So let's go ahead and figure this out. Now this is literally guessing and checking. So let's see what that is. Oops. And again, I'm just guessing. Oops. Keep pressing the wrong buttons too. Oh, you know what? Huh. So I found the answer, but I kept going. So my first original guess was a 0.4, which gave me a value that's too small. My second answer was a 0.45, e to the 0.45 value, which gave me what I needed, but I continued to go. For some reason, I thought this was too big. So it is 0.45. So set those bases equal, set those exponents equal to each other. I'm going to divide both sides by 0.09. And that gives me 5. So what does T equal to? What does T represent? Is the quantity in years. So how long? 5 years. Let's jump to the next one. Asahi invests $2,154, so that's your principal, in a retirement account with a fixed annual interest rate compounded continuously. Again, so we are using that E formula after 20 years, so we know that's our T. It reaches to 3,900, so this is our after. What is the interest rate? So very similar to this one here, except now we're talking about interest rate instead of the years. So let's write out our formula. A is equal to P times E to the RT power. So our A is $3,924.84. Our original investment was $2,154 times E. Our rate is something we don't know. However, we do have 24-hour time. Again, starting off, we're going to divide. And I'm just going to rewrite as 20R instead of R20 on that side. So $3,924.84 divided by 2,154. And again, write down as many decimals as you possibly can. And then we're doing the same base, which then will be 20R is equal to whatever the exponent is. On my calculator, I'm just checking. So the first value that I guessed was a 0.5 or 1/2. It is a little bit too big, so I'm going to drop it down just a tad. So I'm going to do 0.6. If I notice I went 0.6, which I went bigger and the value got bigger, so let's see if I can actually, wait, that's exactly what I need. Oh, did it again. All right, so that means my E value is 0.6. So I have 0.6 is equal to 20R divided by 20. So I have my rate as 0.03. Now remember, rate is your percent interest. So in this case, it is 3%. Let's continue. Number 18 is saying that Daniel invests a sum of money in a savings account with a fixed annual interest rate of 7%, compounded continuously. So again, still continuously. After 11 years, the balance is this. What is the amount initially invested? So now we have our formula. But this time we need to know what the initial investment is. So he has $3,278.53 after 11 years at 0.07, 11 years. So again, don't let E scare you. E is just an irrational number. It does represent a value. So I'm going to evaluate what this is. Don't let that scare you. Or you can simply divide. So if you divide both sides by E to the 0.07 times 11 power, that is just a value. If you were to type this into a calculator, a value would appear. So you're left with, this goes away, this goes away. P is equal to whatever this value is. Again, don't let that scare you. If you don't want to divide by E, that's fine. Take what that value is, but make sure that you are putting the exponent in parentheses, taking all of that value when you are dividing. I choose not to do that. I want to have my answer as exact as possible, so I'm going to divide. And then all of that in parentheses, I'm going to say E to the, again, parentheses for your exponent, and then close all of that. So all of that is in my denominator. I'm going to press enter once, and that gives me $1,518. And then if you look here, our decimal places are 002, which rounds to a whole number. So my initial, I guess not my initial, but Daniel's initial investment is $1,518. All right, moving on to number 19. Julio invests $8,858 in a savings account with an trying to do this fast and already messed up. With a fixed annual interest rate of 7% compounded twice per year. What will the account balance be after 7 years? So in this case, our formula changes because we're not compounding continuously. We're compounding an X amount of times per year, which means our formula changes. Now our formula is going to be A is equal to P times 1 plus R divided by N. N is the quantity of times per year. and then the exponent is n times t. So in this case, our original investment is $8,858 times 1 plus our rate is 0.07. How many times per year? Twice per each year. And for how many years? 7 years. I'm literally going to take all of that and just type that into my calculator. So 8858 times 1 plus parenthesis 0.07 divided by 2, parenthesis, close all of that. Make sure you have enough parentheses, and that's going to be raised to the 2 to the 7th power. You can do that in your head. 2 to the, not 2 to the 7, 2 times 7 in the power spot, which is 14. Press enter and you have your after amount, which is the $14,338.40. Now, in my decimal place, I have a 396, which means I'm going to round to 40 cents. All right, let's move on to number 20. Number 20 says Tutsakan invest $3,303 in a savings account with a fixed annual interest rate of 3%, compounded 3 times per year. How long will it take for the account? So how long? We're trying to find T. T is unknown. For the account balance to reach $4,725.83. So let's write out our formula. A is equal to P times 1 plus R divided by N to the NT power. So our after amount is $4,725.83. Our original investment was $3,303. 1 plus our rate is 0.03 or 3%, and it's compounded 3 times each year. And we're trying to figure out what the T or the time is. Now in this one, you want to be careful. You want to do like kind of PEMDAS. So I'm going to do parentheses first. So I have 4725.83 is equal to $3,303. So I'm going to do the parentheses first and see what that value is. Again, you want to get as precise as you can with your exponents, with your decimals. So I'm going to do 1 plus 0.03 divided by 3. And that gives me a 1.01. For some reason, I expected that to be a much longer decimal. Now that we have our parentheses taken care of, before we can do anything with the exponent, this original value needs to be divided out. And in our calculator, 4725.83 divided by 3303, and I get 1.43076899-ish. And that's equal to 1.01 to the 3t power. Once again, we're going to create same basis, so 1.01 is equal to 1.01 to the 3t power, and we're going to say, what is that equal to? What exponent? And it's a playing guessing game. So 1.01 to the, I don't know, let's try 0.5 power. That does nothing. That gives me just a 1. So let's try 2 to the 2nd power. Well, we're getting to a larger number slowly, so maybe this 1.01 needs to be to the 10th power. 10th power still gives me not a large enough number, so let's do 20th power. 20th power, still not enough. Let's do to the, 30th power. To the 40th power. 40th is too big, so I have 1.488. I need 1.43. So let's dial it down a little bit and try 38. 38 is still too big. Let's try 36. And 36 it is. So if you look at the calculator, 1.4307. So that means my exponent is 36. So 36 is equal to 3t divided by 3 both sides. T is equal to, or the number of years is equal to 12. So how long did it take for you to grow that investment? 12 years. All right, moving on to question number 11. We got 4 more, including this one. So Eugene invests $6,627 in a retirement account with a fixed annual interest rate compounded 2 times per year after 16 years. So you know this is our time. Since it's compounded twice per year, that's going to be our N. After 16 years, the balance reaches $9,111.73. What is the interest rate of the account? And I think I forgot to circle our initial rate or our principal, not rate, initial investment starting amount, so our principal. So let's start out with our formula. Since we are compounding twice per year, we are using our compound formula. So our initial amount was 6,627. 1 plus our rate, we don't know what our rate is. However, we do know that we are compounding 2 times each year. So 2 times our quantity of years, in this case 16 years. And our output is $9,111.73. All right, let's go ahead and start solving for R. R is our unknown value. Since we have R in the parentheses, so like think of it this way, this is a bubble, and that bubble includes our unknown, and we have our exponent. So be careful in that one. Go ahead and start by dividing, and we will need our calculator for that. Now think of it this way, rate is typically a small decimal. It's a percent, but we convert it to a small decimal. So if you get a very small number, that's okay. I'm just going to write out as many decimals as I can. Now you must include these parentheses because you have the exponent attached to everything in here, okay? Now you can't do the distributive property here, okay? You can't, this is not the distributive property. I repeat, this is not the distributive property, but you can't simply do that because of this plus. If we had multiplication, multiplication is king, that would be one of the properties. However, because we have a plus, can't do it. So what we need to do is we need to get rid of this 32, okay? So how do we make this exponent into a 1? Think of it that way. So I can do two things. Let me actually take a pencil because I want to erase this later. To get rid of this 32, I'm going to take the 32nd power on both sides. But I don't have that on my calculator. Do I have that on my calculator? I don't. I have a square root on my calculator. That's it. So on my calculator, what I'm going to have to do is I'm going to have to convert this 32 into a fraction. And what that means is, here's my base. And so my fraction would be, here's my index, right? Index is on the bottom, exponent is on top. So my exponent is 32. My index is 32. Index, exponent. But what really happened, this is what I want to show you, what really happened is I used the power of a power. So I have 32 as my power, and so what I'm going to do is I'm going to raise all of that to the 1/32nd power. And I'm going to do that because 32 to raise to the 1/32nd power, we get to multiply those exponents, which gives us the, I'm going to write it here, the 32 over 32. Now, because I raised this to the 1/32nd power on one side, I'm going to do exactly the same thing. So I have 1.374940. All of that is being raised. You can do it this way here with the index. So what is my exponent? My exponent is 1. What is my index? My index is 32. So that I can do on my calculator. On my calculator, what I'm typing is, I'm going to type in this here. So 9111.73 divided by 6627. I'm actually going to go back and put all of that in parentheses, going to want this to be exact as possible. So 9111.73 divided by 6627, parentheses. Now I'm going to do an exponent of inside parentheses 1 divided by 32. And again, that's going to give me 1.00999. It's a bunch of 9s and then like a 3-5 after that. So I'm just going to put it as 9999. Again, I'm not changing that on my calculator. On my calculator, I'm staying. So then these go away. So I have 1 plus r divided by 2. So again, 1 plus and r are different things. So I'm going to subtract 1 first. And again, this is not a 0.1. This is a 1.00. So if I have a 1.00, this is 0.009999-ish. That's equal to r divided by 2. It's going to multiply by 2 both sides. You do our calculator on this. So I'm going to subtract 1 and multiply by 2 on my calculator. And that gives me 0.0199986-ish. And that's equal to R. Now, R is your rate. Rates are like interest rates, and those are considered to be in percent form, if not inside of the equation. So our percent is 1.9%, or you can say 2%. So 1.9%, or you can just say 2% if you want to round. I'm okay with either. All right, let's go ahead and move on. Natalie invests a sum of money in a retirement account with a fixed annual interest rate of 2%, compounded 3 times per year. After 20 years, the balance reaches $9,305.58. What is the amount of the initial investment? Let me switch over to a pen so it'd be easier for you guys to see. So what do we have? We have our formula. Our output is $9,305.58. We want to know what the initial investment was. Our rate is at 2%. We are compounding 3 times per year for 20 years. Now, this one, our unknown is here, so that way I can do the parenthesis first, and I'm going to try to keep it as exact as possible. So on my calculator, I'm going to do parenthesis 1 plus parenthesis 0.02 divided by 3, parenthesis, close all of that up. I'm going to raise that to a power of 3 times 2 is 6 with a 0 to the 60th power. And so we have this fraction. Now I'm going to take that, not a fraction, that was a decimal. All of that is 1.489845708.3-ish. Since this is multiplication, we're going to divide by this number. I'm going to put a ... there. And we're going to divide. So I have 9305.58 divided by 1.489845708.3. And that gives me 624, just kidding, that's a $6,246.00248. So we're going to round it to the nearest whole number just because we have a 0.00 as our initial investment. Move on. How much will it cost in 330? Round your answer to the nearest cent. In 2010, an item cost $9. The price increased by 1.5 each year. And so how much will it cost in 2030? Here's something I want you guys to notice. This is not compounded. So this is not compounded interest. So this is your basic growth and decay. So this is your f of x or y is equal to a times, in this case we are increasing price, so it's a growth function. And t is our time in years. So our initial amount was $9. We are growing at 1.5 or 0.05. Oh, just kidding, 0.015. And the quantity of years. Now, we're not typing in 230 in here. We want to know the difference between 2010 and 2030. So that means 20 years have passed. And we want to know what the price is. So I'm going to type all of that into my calculator. I have 9 times 1 plus 0.015 raised to the 20th power. And that gives me $12 and about 12 cents. $12.12, your answer would be C. Very last one. Your car cost $42,500 when you purchased it in 2015. If the value of the car decreases, so we have a decay, by 15% annually, what is the price in the year 2022? Same thing. This time we have a decay function. So our initial cost of the vehicle is $42,500. We are decaying, so we have a minus. at a rate of 15%, so 0.15, and the year. So in 2015, 2016, 17, 18, 19, 20, 21, 22. That means 7 years have passed. What is the cost of the vehicle? So on my calculator, I'm doing 42500 parenthesis 1 minus 0.15 parenthesis with an exponent of 7. And that means if the car decreases at 15% yearly or annually, the price of the car in 7 years will be $13,624.52. In this case, they're giving us whole numbers, no decimals, and I'm looking for 13,624. In this case, they rounded it to 13,625 since this is a 5 or greater. All right, beautiful people, this wraps up your full review. This is part 3. Thank you so much for watching, and I will see you in my next video, and good luck on your test. Bye!